Now we'll see the applications of BFS and DFS. One important application of BFS and DFS is finding the cycle in the graph. We start with that. So why finding the cycle in the graph is important in computer science, I will tell you. Take one requirement which is in operating system. In operating system, let's say we have some programs P1, P2, P3, P4. Let's say, so P1 is depending on P2. That means to complete P1, P2 should be done. To complete P2, P3 should be done. In that way we have requirements. Let's say if I represent that requirements, it forms a graph, right? So let's say see these requirements. So in this graph, P1 is depending on P2, P2 is depending on P3, so on, and P4 is again depending on P1. So to complete P1 we have to complete P2, to complete P2 we need P3, to complete P3 we need P4, to complete P4 we need again P1. So none of them can be completed, right? So that's the reason is there is a cycle, right? This is called deadlock. To avoid the deadlock we have to detect the cycle, right? So how to find out the cycle is very important application, that's why in operating system. For that we are going to find out now cycle. So it is our graph problem. Given a graph, how to find out a cycle in that graph is a question, right? How effectively we can do, we will see. So depth first search, otherwise breadth first search we can use to find out the cycle. Let's begin with undirected graph. Okay, so first I will give you the simple algorithm. After that I will tell you the reason for that. Okay, let's begin with algorithm first. I am using depth first search. So what you do is, given a graph like this, which is undirected graph first. So A, B, C, D, let's say D to E, E to C. So follow this algorithm. Blindly do DFS, and what you do is, remember this thing. Every time when DFS call is made, so check this condition. In this DFS call, whenever you see a visited, whenever you are exploring in DFS, what you do? Generally we explore the vertices, correct? Let me recall DFS algorithm. First of all, let's begin with A. If DFS is called on A, what happens is, first we will go to the linked list of corresponding A, correct? A will have neighbors. What are the neighbors? A has B, correct? Similarly, D has neighbors C, E. Assume that in adjacency list C is first, after that E, in an alphabetical order I am following. Okay, now if that is the case, first of all in DFS of A, we will try to go to neighbor of A, which is B, correct? Since B is unvisited, and one more thing, we maintain a visited matrix, otherwise color matrix, both are same, their functionality. So let's take A, B, C, D, E. This is visited matrix. In that, so DFS of, first of all, this is visited already now, correct? Now we are exploring this edge. After seeing this edge, I realize that B should be processed. That means we have to call DFS of B. So that's why I say that I am exploring this edge, right? So for that, B should be unvisited. Yes, B is unvisited, then make it visited. Called DFS of B. In the DFS of B, did you remember? First step itself is making this B, gray. Making gray is nothing but visiting it. That's it. After that, what happens in the DFS of B? First step again, going to the loop. What is that? Exploring all the neighbors of B. What are the neighbors? B has A, C. Since A is already visited, that's why we don't call DFS of A again, correct? So we, instead of that, we call DFS on C. So what I want to say is, in this cycle detection algorithm also like DFS, but what I do is, every time when DFS call is made, I will check like this. Example, while exploring the neighbors, as usual, example B's neighbor is A, right? A is already visited. If any vertex is visited while exploring the neighbors, but it is not parent, that means B's parent is not A. And one more thing, we maintain the parents list, right? A's parent is initially nothing. B's parent is A, in that way. If at any time when you see a visited matrix again while exploring the edges and that visited matrix is not parent, then definitely there is a cycle. Okay. Now at this moment, while exploring B's neighbors, we have seen C. Before that, first we have seen A, but A is already visited. Leave it. A is visited, but B's parent is A, correct? So that's why leave it. Now explore the next edge. So this edge, when you are exploring this one, so you see C, correct? C is not visited, make it visited. For that we call DFS on C. So this is the way we run the DFS algorithm, we know that. Okay. Now if you don't understand this one, that means you did not understand DFS algorithm. Please go through DFS algorithm and execute on your own first. After that, come here. Now DFS on C. On DFS on C, what we do? We take every neighbor. First neighbor is B. So B is visited, yes. So then one more condition. If it is visited, what is the parent of C? parent of C is B itself, correct? We know that. Because through B we reached C, then B is the parent of C. So then leave it. If B is not parent of C, then definitely there is a cycle. Let's continue. So C to D. So we know that next we'll go to DFS on D. On that first step is we mark D. Then after that we start exploring D. In exploration, first we explore this edge. Well, when you explore this edge, C is the end, right? Since C is already visited, but D's parent is C, so don't do anything, continue the process. Then in the process, from DFS of D, we will go to DFS on E. And one more thing again, start processing neighbors of E. Who are the neighbors of E? One is ED, that means D, one is C. Let's follow some systematic way. So assume that, let's say we are first exploring E to C, because I said neighbors of E are in adjacency list, are in ascending order, otherwise alphabetical order. So E is first neighbor, let's say C. Then C is already visited, right? Yes, C is already visited. Now, what about C? Then is this C visited? Yes, C is already visited. Now see here, E to C, correct? Now, is this C your parent? No, your parent is D, correct? Now, that's why there is a, whenever you are exploring E, so you got one vertex which is already visited, condition number 1. Second condition is it is not your parent. Stop it, then definitely I can say that there is a cycle. That's it. So you can detect the cycle. If you want to know the cycle, we can find it out, not a problem. So finally, this is the way we detect the cycle. Now we'll see one more time to understand it clearly. So always these two conditions should met. One is, so first thing, while exploring your neighbors, that neighbor is already visited. Second one, he is not your parent, then definitely there is a cycle. Let's try one more time with a simple problem. Let's take this one simply. A, B, C, D. Adjacency list, what I was talking about is like this. A's neighbors are B, C. Okay. B's neighbors are, A's neighbors are B, D. I'm sorry. Now B's neighbors are, one is C, one is A. So I'm giving the order here. So C's neighbors are, let's say, D, B. In the previous problem I did not give, now I am giving, then any order I can give. In the previous example I did not give the order, that's why I said follow alphabetical order. So in D, D's neighbors, let's say A, C. Right? For this problem, we will see how to do DFS and how to detect the cycle. Start first DFS on A, anywhere. So first DFS, A's parent is nothing. Now first what happens, we try to explore all the edges. First edge is B. Then since, and one more thing to be maintained is this matrix, right? Visited matrix. So initially A, B, C, D, nothing is visited. So first DFS of A now just now visited and we are exploring A's edges. First edge, let's take A to B, correct? Now while exploring this edge, you realize that B is not visited, mark it, continue the process. Now DFS of B. First step in DFS of B is visiting it, done. Then what to do? Explore B's neighbors. First neighbor of B is what? C. Go to BC edge. That means, we are processing this edge. On behalf of this edge, go to C and see if it is visited or not. Yes, it is not visited. So immediately call DFS of C. And one more thing. So here through A you reached B, right? B's parent automatically will become A. So we have a pi matrix. Did you remember? Using that pi matrix we can maintain these values. We already maintained in the program. Please go through the program, that's why. Now parent of B is A. Now we reach DFS of C. Now that's why parent of C is what? B. Now explore all the edges of C one by one. So who is the first edge of C? D, correct? So explore CD. So if you explore CD, you encounter D. Before that, in DFS of C, first step is what? Marking C. Then D. Is it visited? No. When it is not visited, call immediately DFS of D. Mark it. That is the second step. After that, update the parent. Parent of D is now C. Now, we are now in DFS of D. Now, what is the first neighbor? A. Correct. Is it visited? Yes. At least, is he parent of D? No. If A is not a parent of D and you already visited, means definitely it forms cycle. That is what. That's why. So this is cycle detection algorithm. So in undirected graph, in that way easily we can find out the cycle. We are not doing anything extra, right? So we are simply doing DFS. While doing DFS itself, so we are simply putting one or two conditions in the code, correct? That's why I can say that time complexity of detecting the cycle is order of V plus E, not more than that. Okay, so if you want to really detect the cycle, we can do in order of V plus E. Now we'll see how to get the cycle. That means I would like to know where is the cycle. So you found the cycle, right, within order of V plus E time, but how to get the cycle where it is actually A, B, C, D, correct? So now I will tell you how to detect the, how to get the cycle back. For that, already you are here, right? So you realize that D to A there is a cycle, but already you reach D from A to D like this, correct? So what we do is you started here, stop the algorithm here, DFS algorithm. So take the parents back, see C, B, A. You started D and go to C and C to B, B to A, right? This is a cycle A to D, correct? So the simple idea to get this cycle back is accessing this pi matrix. Did you remember one thing? Already we know that D's parent is in the pi matrix, D's parent is C and C's parent is B and B's parent is A, correct? Now when you identified cycle when you are at D, what you do is simply go to D and push the parent into the stack. What is that? C. Next, go to C, push the parent into the stack. Now go to B and push the parent of B to stack. So stop it because you reached A. Whenever you reach A, stop it. Then print them one by one. A, B, C, and D is the vertex where you detected it, right? Add it. So I can say that the cycle is A, B, C, D. Otherwise, you can add D to the stack also. What you do is start detecting the cycle like this. Push D into the stack until you reach A. Keep on doing one thing. What is that is? So push D and after that push parent of D, C. Now push parent of C. We can use this matrix to know the parents. Push parent of C, B. Push parent of B, A. Now when you reached A, stop it and pop everything. You get the cycle. What is that? A to B, B to C, C to D. In that way, so we can say that this is a cycle. What is the time complexity extra we are taking apart from order of V plus E? How much time this will take? What is the length of the stack? Simple. If you have n vertices in the graph, otherwise V vertices, so I can easily prove that the cycle length can be at most V, right? No one can have more than that. With V vertices, your cycle can have at most V vertices, right? So that's why cycle length will be at most V. If cycle length is at most V, then this stack also will grow only up to V vertices, correct? You can't have more than V vertices in the cycle. So this stack is going to represent the cycle length. If cycle length is V, stack length also V. That's why I can say that. So you are pushing V vertices at most. I am not saying that always V, but at most V vertices into the stack and you are popping them back. It takes order of V time, correct? Because push takes 1 unit of time, pop takes 1 unit of time. So V pushes, V pops takes 2V time. So V plus E plus 2 into V asymptotically order of V plus E. Finally, given undirected graph, finding cycle takes after all order of V plus E time. Okay.